Hi everyone. So we are going to do the next few lessons as a flipped format, which means you'll be doing some notes at home on these videos, and then in class we'll do some practice and you'll get to work together and ask me questions in class. So we are primarily doing them in this unit because it is a review from Algebra 1 and Algebra 2. So those of you who are comfortable with this and you feel like you understand it, you'll be able to jump right into the stuff that we're doing in class. But people who need a little bit of extra help in class, you'll have me there to help you through. So first thing we're going to start off with is graphing and solving word problems from Vertex Form. So here are the things that we're going to label. We're going to label the vertex, the axis of symmetry, which is right here. This is the vertex. You can see along that axis of symmetry we have a mirror image on both sides. The x-intercepts, if they exist. So those are my x-intercepts. We'll list exact and approximate values. So if they're, have a square root in them, we'll list them in simplest radical form. That's exact. And then we'll plug them into our calculator and round them to get the approximate ones. And then the y-intercept. So if x-intercepts don't exist, we're also going to plot a symmetric point. So if I'm looking over here at this diagram, here is my y-intercept. A symmetric point to that would be the reflection of that point over the axis of symmetry. So my symmetric point would be right here. So vertex form, that is y equals a times x minus h squared plus k. So it's called the vertex form because my vertex is hk. And standard form is y equals ax squared plus bx plus c. So if I'm looking at this function, y equals 2 times x minus 1 squared minus 2, the x value of my vertex, if you notice up here, it's minus h, but that gives me a positive h value. So even though this is minus 1, my x value is positive 1. So that's the h value of my vertex. And the y value is whatever you have on the end. So that is my k value. So that is negative 2. So the vertex is 1, negative 2. The axis of symmetry, so if I'm looking at this diagram again, the axis of symmetry is a vertical line. Vertical lines always have an equation of the form x equals a number. So since it's going to always pass through the vertex, that x value is going to be the x value of my vertex. So my axis of symmetry is always going to be in the equation x equals my h value. So for our example here, I'll have x equals 1. The y-intercept, I need to substitute in 0 and for x and solve for y. So we would get y equals 2 times 1 minus 2, so that's going to be 0. So my y-intercept for this problem, my x value is 0 because I plugged in 0 in for x, and the y value that we got out was 0. My x-intercept, if I'm solving for an x-intercept, we make y 0, and I solve for x. So I'll add 2. So we have 2 equals 2 times x minus 1 squared. I'll divide both sides by 2, so that gives me 1 equals x minus 1 squared. And when I square root both sides, I get plus and minus 1 equals x minus 1. So then I add 1 to both sides, and so I get x equals 1 plus and minus 1. So 1 plus 1, that's going to be 2. So one of my x-intercepts will be 2, 0. And then 1 minus 1, that's 0. So my other x-intercept is 0, 0. So the symmetric point, in this case, for my y-intercept, we don't need it, but I'm going to start to plot this stuff, and then we can take a look and get that. So we have our vertex is 1, negative 2. Our axis of symmetry is a vertical line through that, so x equals 1. I have a y-intercept at 0, 0. And x-intercept at 0, 0, and 2, 0. So again, if I needed a symmetric point to my y-intercept, it would be a reflection over this axis of symmetry, so it would just be at that 2, 0 point. And I'll just connect that to make my parabola. That is everything we need. We have our vertex, axis of symmetry, y-intercept, x-intercepts, and symmetric point. So let's do a couple examples here. The vertex on this one, so remember it's x minus h. So if I have a positive 2 there, that means I'm going to have negative 2 as my x value of my vertex because it's x minus negative 2. And then my k value is negative 1. So I'm going to start plotting that. Negative 2, negative 1. My axis of symmetry will be a vertical line through that point. So my axis of symmetry is x equals negative 2. My y-intercept, I'm going to substitute in 0 in for x and solve for y. So that's going to give me 1/2 times 4 minus 1. So that's 1. So my y-intercept is 0, 1. We're going to have x-intercepts here, but if I wanted a symmetric point, this point is 2 units away from my axis of symmetry, so if I go 2 units in the opposite direction, my symmetric point is at negative 4, 1. And now to get the x-intercepts. So I'm going to start from here. I have to make y 0. I'll add 1. Multiply by 2, square root both sides, so we get plus and minus root 2 equals x plus 2, and then I have to subtract 2. So that gives me negative 2 plus and minus root 2. These are my exact answers, so let me label that. Exact will be negative 2 plus and minus root 2, 0. My approximate ones, I'll have to take that and put those into my calculator. So my approximate values for negative 2 plus root 2, I get negative 0.59, so we'll go to the hundredths. And then for negative 2 minus root 2, we get negative 3.41. So I'm just going to plot those the best that I can. So negative 0.59, negative 3.41, and then I'll connect to make my parabola. Okay, this next one, my vertex should be 3, negative 1. The axis of symmetry is the vertical line that goes through that, so that's going to be x equals 3. My y-intercept, we have to plug in 0 in for x and solve for y. So that's going to give me, let's see, negative 1/2 times 9 minus 1. So negative 9 halves minus 2 halves would give me negative 11 halves. So that's negative 5.5. So my symmetric point, if we reflect that over the axis of symmetry, we'll end up at negative 6, negative 5.5. And now before we go ahead and start solving for x-intercepts, what I want you to pay attention to is what we have graphed already. So I have this vertex here, and I have these 2 points. So that really means this parabola is going to open down. So that means it's never going to cross over my x-axis. So I'm not going to even bother solving for x-intercepts. I'm just going to say I have none. So you don't want to just ignore x-intercepts, leave that out altogether when you see that it's none. I still want you to say that we have none. And then we'll go and make our parabola. Okay, for this last one, our vertex is at 4, 1. My axis of symmetry will then be x equal 4. My y-intercept, when I substitute in 0 in for x and solve for y, I get y equals 3 times 16 plus 1. So that's 49. So we have quite a big value for this. My symmetric point to this, if I were to get that one, it's at 0, 49, somewhere way up here. So it's 4 units away from my axis of symmetry, so I'd go 4 units in the opposite direction, which would give me a symmetric point of 849. So if you would like to, we can adjust our scale so that I can actually plot that. Let's see, I'm going to erase my vertex, and I'm going to change my scale here. I'm going to do it by tens. Let's do it by fives. So this will be 10, 20, 30, 40, 50. So 4, 1 is going to be really close to my x-axis. I'll have 0, 49 way up here, and then 849 way over here. And one more thing to point out in this case, again, where vertex is above the x-axis and the parabola is opening up, so it's never going to cross the x-axis. So for our x-intercepts, again, we have none. So then I'll just go ahead and connect my points. If you didn't want to do it with the 0, 49, another thing you could do is instead plug in a value that you can plot. So in that case, since my vertex is at 4, I might plug in 5. So we would have 5 minus 4 squared plus 1. So that is going to give me 4. So some points that I could plot, I would plot 5, 4, and then since 5, 4 is going to be 1 unit away from my axis of symmetry, I would just reflect it over and get 3, 4 as another point to plot. Now to finish up, we have a couple word problems. The first one is about daily profit, but it's given to you in vertex form. So the daily profit P of a small clothing factory and the charge C for each dress is expressed by P equals negative C minus 60 squared plus 1600. What should you charge for each dress to get the maximum profit? So anytime you see maximum, maximum, or minimum, you want to think vertex. So max or min, we want to think about the vertex. But we do have to consider, like, which piece of the vertex am I using? Am I using the h or am I using the k? So if we think about our coordinates for this type of function, my x value is c and my y value is now using p. So since a vertex is hk, anything that describes cost, the cost that would maximize the profit, I'm going to use the h value of my vertex. Anything that asks for the maximum profit itself would correspond with k, which is the maximum profit that the clothing factory can make. So for part A here, since my vertex is 60, 1600, this is my h and this is my k. Remember, and this is a c value, this is a p value. So what should you charge? Well, 60 is corresponding with a charge, so you should charge $60. The maximum profit itself, that's corresponding with a k value, so the $1,600 will be the maximum profit. And then it says, how much profit does the company make if they charge $50 per dress? So this is a c value. So I'm going to take my function and I'm going to plug in 50 for c. So when we simplify, we get negative 100 plus 1600. This is going to be $1,500 for my answer for part C. In the next type of example, we're told the sum of the squares of 3 consecutive integers is 149. So what I'm looking at here, if I want to look at consecutive integers, and I call the first integer x, then my next consecutive integer is just x plus 1, because that's just my next number. And we need 3 consecutive, so x plus 2 would be the one after that. So we're saying the sum of the squares of these, so x squared plus x plus 1 squared plus x plus 2 squared is 149. So that is the sum, because I'm adding them, of the squares. I'm squaring all 3 of them. So now I need to FOIL a little bit. So that's x squared plus 2x plus 1. And this one's x squared plus 4x plus 4. I'm going to combine all my like terms. And I'll have to subtract 149 to the other side. Now these are all divisible by 3, so if I come up here, I can take out a 3. I get x squared plus 2x minus 48. And this is factorable. So that will factor into x minus 6 and x plus 8. So we get x equals 6 or negative 8. Okay, so I actually end up with 2 different sets of answers. So if x is 6, then my integers are 6, 7, 8, because that will be x, x plus 1, x plus 2. My other set of integers, if x is negative 8, x plus 1 would be negative 7, and x plus 2 would be negative 6. So we'll end up with 2 different sets of answers. So you want to give both sets. On our last problem here, it's the sum of the squares of 3 consecutive odd integers is 11. So when I'm looking at consecutive odd or even integers, this is how we'll define them. The first one I'll call x. if I want my next odd integer, I have to skip over one, so that's going to be x plus 2. And then I'll have to skip over the next one, and then I'll have to go to x plus 4. So we end up with the sum of the squares of these three, so x squared plus x plus 2 squared plus x plus 4 squared. That is going to be 11. So again, I have to expand and solve exactly like the last problem. I'll combine all my like terms. Subtract 11. I can take out a 3. And then this factors x plus 3, x plus 1. So we get x is -3 or -1. So for my answers, if x is -3, then my second one would be x plus 2, so that's -1. And my third odd would be x plus 4, so that's +1. My other set, if x is -1, then x plus 2 would be +1, and x plus 4 would be +3. So those are my two sets of answers there.